Just a few kilometers from Shanghai in northeastern China, thousands of women and men work in a humongous shipyard. This extraordinary project is an unparalleled technical and human challenge. Not one, but 9 container ships are built here. These 9 steel giants are among the largest in the world. The work will take place simultaneously and will last just under 2 years. The shipping company behind this new generation of ships is France's CMA CGM, a world leader in ocean transportation. These giants will transport an enormous amount of goods, approximately 215,000 tons per freighter. The first is the Jacques Sadé.
Le CMA CGM Jacques Sadé fait 400 mètres de long, 61 mètres de large, 70 mètres de haut, avec 300 000 tonnes de déplacement au maximum, 16 mètres sous l'eau.
These ships mark a turning point in nautical transportation due to a revolution in the engine's energy supply of liquefied natural gas. A symbol of this innovation, a revolutionary tank filled with liquid natural gas, cooled to -161 degrees. The liquid natural gas is more environmentally friendly than oil. It powers a unique motor, the largest natural gas-powered engine ever built. It's just under 20 meters high, about as tall as a 6-story building. This engine drives a huge propeller, 10 meters in diameter. Each of these ships is capable of carrying 23,000 containers. Lined up in a row, they'd cover a length of 150 kilometers.
On peut charger jusqu'à 12 conteneurs les uns sur les autres et 22 conteneurs dans la largeur. Il y a 11 cales comme celle-ci à bord du Jacques Sadé.
We follow the construction site manager and shipboard commander into the heart of the command center and get to experience the key moments in the construction of these mega ships up close. Will it be possible to complete the 9 giants in a record amount of time? What technology is used in such a gigantic shipyard? The story of these container ships presents a massive challenge. How do you build 9 ships in less than 2 years when it normally takes 18 months to build just one? This gigantic shipyard was built to make it happen. There's enough space here for all 9 ships and the necessary infrastructure. The shipyard is located on the other side of the world, in China, just outside the city of Shanghai on Changxing Island. The shipbuilding facilities extend almost 4 kilometers. There are 3 dry docks in the shipyard to get as much done as possible at the same time, so the ships can be worked on one after the other. There aren't many giant shipyards like this, where several dozen megaships are built each year. Most of them are located on the Asian continent, where there's a significant pool of expertise. The shipyard is like a city where more than 6,000 tradesmen, technicians, and engineers work from all over the world. The challenge is enormous. Each ship will be able to load up to 23,000 containers. A first. The dimensions set completely new standards. 400 meters long, or the length of 4 soccer fields. 61 meters wide. Just under 78 meters high. That's higher than the Statue of Liberty. Without cargo, a ship like this weighs 70,000 tons. Intense vigilance and rigorous organization are essential at all levels for these behemoths to be completed in time. In one of the shipyard's many warehouses, workers are building a section of the ship called a block. A special system is used to coordinate the production of the 9 ships, similar to a giant Lego. The ships are assembled in the dry docks in huge basins. One by one, the blocks are delivered and welded together, an extremely efficient construction method. Each block has a precise function and specific place in the overall construction of the ship. To produce these giant vessels without wasting time, the construction plan was broken down into thousands of independent blocks, like an assembly line. And to save even more time, everything's already installed. Piping, fittings, ready to be connected. These huge parts are brought to the center of the shipyard near the dry docks, where they're mounted on the part of the ship already built. Like a skeleton, every single part of the ship becomes visible.
Donc là, on a un bloc qui n'a pas encore été assemblé, donc ça nous permet de voir une coupe de la structure de la coque du navire. Donc ça, c'est l'épaisseur de la coque du navire.
These floating giants have a very thin but extremely strong outer wall. A complex puzzle with countless pieces.
Il nous faut environ 399 blocs pour assembler la coque. Chaque bloc va peser entre 150 et 300 tonnes. Une fois prêts, les blocs vont être soudés entre eux.
All parts need to be assembled with surgical precision. Part of the tail, consisting of 5 blocks, slowly moves towards the basin like a spaceship from Star Wars. 790 tons, the weight of 2 high-speed trains, floats in the air. No problem for the massive port cranes, which can lift up to 600 tons. 2 cranes working together. The assembly of the massive parts has to be perfect. But how's it possible to build the ship without blocking access to the bottom of the ship? How can individual parts be protected from getting damaged on the ground? The trick? Small, incredibly stable support beams, known in technical jargon as pawls. The pawls are placed on the bottom of the basin so the ship can be placed on top. A pawl consists of a concrete block with a metal structure attached on top. Each one can carry 200 tons without damaging the hull. Together, the pawls support the weight of the completed ship, nearly 70,000 tons. Everything's ready for the next mega ship to be assembled. In the beginning, there was sheet metal, 12,661 steel sheets. They're the raw material for the structure of container ships. Just like cells in the human body, they're delivered by sea, by the hundreds. The structure of the ship is made of these sheets, mainly steel, a material that can be used over and over again.
La beauté d'un navire, c'est qu'il est à 99,9% recyclable.
When the ship's dismantled in 30 or 40 years, almost all the parts can be recycled. This sheet metal field is located near the warehouse. Thousands of plates are waiting to be cut to size. But why are increasingly larger container ships still being built? Reducing the cost of transportation isn't the only reason. environmental factors also play a vital role. If 23,000 containers can be transported by one ship, the life cycle assessment of each of these containers improves.
Nous avons juste un moteur, certes, beaucoup plus imposant que celui d'un moteur de camion, mais qui, en soi, va polluer moins que les 23 000 camions qui vont transporter leurs conteneurs d'un bout à l'autre.
So sea transport is comparatively more environmentally friendly than air or road transport. Propelling increasingly large ships while being environmentally friendly is a real challenge. One of the main challenges of the early 21st century is to keep the carbon footprint as low as possible. So a revolutionary propulsion system was developed for the 9 ships. Unlike older generations of comparably larger container ships, it no longer operates using oil, but rather it's powered by liquefied natural gas. Some smaller ships are already powered this way, but the use of this fuel in a container ship with 23,000 units, that's innovation.
C'est une grande première mondiale. C'est la première fois qu'on va construire un moteur de cette taille et de cette puissance qui va fonctionner au gaz.
The choice of this fuel represents an important advantage, a drastic reduction in greenhouse gas emissions. A trip pollutes the environment far less than using oil. Liquefied natural gas is certainly progress in the race to reduce the carbon footprint of cargo ships.
Le gaz naturel liquéfié permet de réduire de 20% les émissions de CO2, de 85% les émissions d'oxyde d'azote, de 99% des oxydes de soufre et les particules.
A considerable improvement. But the engineers also face a second problem, a ship's independence. The majority of routes run between Asia and Europe, so fuel supply is an important core issue. The fewer stops a ship has to make along the way, the lower cost and travel time. Container ships powered by liquefied natural gas have to cover enormous distances without any intermediate refueling. Storing such an enormous amount of liquefied natural gas on board presents a complex challenge. The French company GTT, world market leader for liquefied natural gas tanks, developed a customized solution for this project. It's the largest tank ever built. 51 meters long, 27 meters wide, the tank measures 18,000 cubic meters, as much as 6 Olympic swimming pools. The liquid gas offers a huge advantage and solves a familiar problem.
Le volume occupé par le gaz, une fois transformé à l'état liquide, est 600 fois inférieur au volume qu'il occupe à l'état gazeux. Donc vous concentrez un volume de gaz tout à fait considérable à l'état liquide.
The requirements are intimidating. To ensure the gas remains liquid, it needs to be stored between -161 and -163 degrees Celsius. So the tank has to not only withstand the temperature, but also be able to maintain it. To do this, all the inner walls are covered by several layers of insulation, which is more than 27 centimeters thick. So the tank is similar to a casket, dense and durable, like a giant freezer in the center of the ship. After a 6-month phase of block assembly, a new stage begins, installing the tank. To do this, a block must be completely isolated, a lengthy and critical stage that requires meticulous precision, and which can last up to 9 months. How can the natural gas be perfectly insulated at -161 degrees, and in a tank exposed to wind and weather on the high seas? To accomplish this, 27-centimeter thick sheets of polyurethane are used. They protect the outer walls from the extreme cold. The panels are glued to the walls of the tank and then fastened. That's why the tank is divided into several levels, so workers can cover the entire surface of the huge hull, a work phase that takes 7 weeks. The first layer of insulation is ready, but is it absolutely airtight too? Even though it's always a race against time on the construction site, the crews still have to make sure everything's working properly and check every single seam. The work's divided into inspection zones. A leak was found here. In such cases, technicians use an efficient method, which is surprisingly simple.
Water.
The affected section is covered with soapy water. Then this plexiglass box is used.
Yeah. Let's see here.
A vacuum is created inside with a pump. If air bubbles escape through the inner wall, it proves the seam isn't completely airtight. Then you need to glue that spot again, of course in a timely manner. It's important not to waste a minute. The procedure needs to be repeated on the lower levels. The countdown continues. After 16 weeks, the first stage of installing the tank is complete. A second, much longer stage is about to begin. The tank is the energy reservoir of the ship. From here, the liquefied natural gas is routed to the engine. The problem is, both the gas volume and the distance to be covered are extensive. Because of balancing, the engine is located at the other end of the ship. So a suction mechanism needs to be built into the tank. Here it comes. Its weight, 25 tons. Its task, to pump the gas to the engine. Its name, the gas mast.
Le mât gaz va supporter un élément fondamental du fonctionnement du navire, c'est-à-dire les pompes qui vont alimenter la chaîne gaz, lequel gaz va alimenter le moteur.
The engineers had to design a mast that is virtually indestructible because it needs to withstand extreme conditions in the tank.
Dans cette cuve, on a des mouvements de gaz liquéfié à moins 161 degrés.
The lower the tank gets, the more waves of liquid gas beat against the mast, located in the center of the tank.
Et il va falloir que ça tienne pendant extrêmement longtemps. Donc, c'est du très solide. C'est quelque chose de très impressionnant à voir.
The mast needs to withstand freezing cold and enormous pressure without moving even a millimeter, and do that for several years. Work continues at the enormous Shanghai shipyard. A tank obtained its first layer of insulation on one of the container ships. Now a second one can be attached, but the gas mask needs to be installed before that. It's lowered into the tank from the top. The mast is 6 meters wide, and the opening through which it's lowered is barely larger. The mast is lowered centimeter by centimeter. Around 15 workers are involved in this delicate operation. The metal monster floats in the air. Finally, the mast is now securely attached. There are 4 pumps at the lower end, just a few centimeters above the bottom of the tank. They pump every drop of the liquid gas.
Quand on voit ça, on se demande mais comment c'est possible? Comment ça va tenir? C'est suspendu au toit de la cuve et ça descend jusqu'en bas avec la pompe qui va pomper le liquide au plus près du plancher de la cuve.
A device that's proven its reliability. Now the tank's last layer of insulation is added, the so-called primary membrane, a 1.2 millimeter thick sheet metal. It's what gives the tanks their waffle-like surface structure. this membrane is ultra-thin and at the same time incredibly efficient. The intense cold of the liquefied gas causes the steel to warp, so it's crucial that the structure itself is flexible. The embossed membrane with its wavy edges offers the perfect solution.
Son génie, c'est la souplesse qu'elle a. Et cette souplesse, elle est produite par ces ondes. Ces ondes sur ces plaques d'acier inoxydable qui vont se contracter sans exercer d'effort sur les kilomètres de soudure qu'il y a dans la cuve.
Weld seams totaling over 6 kilometers run through the tank. They're extremely resistant. The same technology is also used in space travel. After 8 months of work, the tank is finally ready. A final inspection takes place before it's finally closed. Nothing, not the smallest speck of dust, is allowed to be left behind. The ship should be ready in 4 months. Today, 3 months after work began, is a special day for the engineers. They've come to the mainland because one of the core pieces of the project is being completed in these halls today. One of the most spectacular individual parts of the ship, the engine. With its 24 meters length, 18 meters height, and a weight of 2,000 tons, it generates an output of 85,000 horsepower. A genuine independent construction. Before the engine's mounted in the ship, it's tested to the extreme. The engine's pushed to its limits, to 110% of its capacity. This test is absolutely necessary to check the stability of the motor in extreme situations. Repairing this massive component on the open sea would be extremely complicated. And it was actually developed to simplify the work of mechanics. If there are any serious problems, mechanics can enter here to the center of the engine. But the tests went well. The engine passes with flying colors. It'll be installed in one of the 9 container ships in a few days. Nine ships. That's 9 engines that have to be built in a very short amount of time. So they're manufactured just in time. The second engine's already being assembled just a few dozen meters away from the first engine. A critical step is about to be taken. The main piece will now be delivered, the crankshaft. The crankshaft is the axle that connects the engine to the propeller and powers it. Its weight, 220 tons. It's mounted in the lower part of the engine and moves with the help of 12 pressure pistons.
Là, on est sur le cœur du navire. C'est ça qui va transmettre la puissance, c'est le muscle du navire.
First of all, the part is thoroughly oiled. The pressure pistons are connected later when the crankshaft's in place. This is genuine engineering. Almost 220 tons are waiting to be installed. This is done with the help of extraordinary cranes. So far, this is only half of the crankshaft. The 12 pressure pistons each have a diameter of 1 meter. That's 10 times more than a car. When running, they move 3.2 meters up and down. The engine's now mounted onto one of the ships. But before that, it has to be taken apart to be brought on board. And it's not that simple. No vehicle in the world could move this 2,000-ton massive part. That's why it's separated into 6 parts, transported individually by ship to the shipyard. This is the main part. It includes the crankshaft. The crankshaft is carefully lowered. With its weight of 350 tons, any unprotected contact with the ground would damage the metal. So it's carefully loaded onto beams. Even though the beams are temporary, they're still attached carefully. Now this highly sensitive piece of the engine is loaded onto a peculiar cart.
Cette pièce pèse 350 tonnes et pour la transporter de l'usine jusqu'à la grue qui va finalement la mettre sur la barge, on utilise un chariot. Ce chariot, dans notre langage, s'appelle une traîne.
To endure such a great weight, these transporters have up to 140 wheels. They weigh more than 10 semi-trucks. And they're controlled by remote control from a distance. Because safety's a top priority, the transporter only travels approximately 5 kilometers per hour. The ship's already waiting when the transporter reaches the barge. The engine's loaded as slowly as possible. Everything's ready to transport it to the shipyard. To get the container ships moving, which can weigh up to 300,000 tons when fully loaded, the propulsion system has a propeller with a very distinctive form. Their streamlined shape delivers increased performance.
Les pales sont étudiées de manière à ce que les filets d'eau le long de la coque et qui arrivent à l'hélice aient un passage optimum. Le nombre de pales est aussi étudié pour diminuer la consommation en combustible.
Back on the island, in the heart of the shipyard. This part was designed in Germany and made in China.
Voici l'hélice. Elle pèse 92 tonnes pour 10 mètres de diamètre. Et c'est cette unique hélice qui va permettre de propulser le navire à 21 nœuds, ce qui représente environ 40 km/h.
The propeller is connected with this huge round steel piece. The propeller shaft causes the rotation.
L'arbre porte-hélice va transmettre une puissance de 85 000 chevaux à l'hélice. Donc le but du test aujourd'hui, c'est de s'assurer que la surface de contact entre l'arbre et l'hélice soit parfait.
In other words, the two parts have to be 100% aligned. There can't be any discrepancy whatsoever. At full speed, the slightest inaccuracy would have irreparable consequences. A dye is used to perform the test, methylene blue. Now the two parts come together. The blue color shows exactly where the contact points are. A job of absolute precision, which can't be tampered with.
52.5. 5, 2. Okay, now 52, it's okay.
The propeller shaft is raised one piece at a time. The propeller and propeller shaft fit perfectly into each other.
Là, on a un résultat parfait, on a 100% de contact, donc c'est super.
The operation was a complete success. In the next step, the two parts are finally assembled on board the ship. Because the construction of each ship is progressing at different stages, the quality and cutting of the sheets must be constantly monitored. The metal's cut with a laser beam. Generating heat of approximately 18,000 degrees Celsius, it cuts the steel like butter. In total, more than 880 kilometers of metal sheets are required for one ship. That's the distance between Paris and Berlin. There aren't any high-tech robots here and very few automated processes. Everything's done with industrial machines and human hands. Every worker has a place. This is where the first parts of a new ship are taking shape. These plates can now be assembled together to form new blocks. Work at the shipyard is carried out in several stages: by design, expansion, and inspection.
And now I want to see this, if it's good.
It's now time to assemble the last block. It's already waiting a few meters from the basin. André supervises the operation. The block is slowly lifted up, hovers in the air for several minutes, then fits perfectly in its place in the bow of the ship. Now it just needs to be welded in place, and the ship will be completely finished. These ships are gigantic metal construction sets, but they're also extra-large patchwork rugs. The connecting seams stretch across the entire hull like scars.
Là, en fait, on a deux blocs qui ont été préassemblés. On voit bien le joint ici, qui n'a pas encore été soudé. Et donc tout cela est assemblé par soudure. Et il faut 1248 km de soudure pour complètement assembler la coque du Jacques Saadé.
1,248 kilometers. That's the distance between Marseille and Manchester. Sparks are flying all over the shipyard. Thousands of sheets are welded at the same time. Once the ship's at sea, there can't be any structural weak points. Like a weak link in a chain, the slightest mistake at sea can mean disaster. That's why every weld is meticulously inspected and redone if necessary. The simultaneous construction of the 9 container ships continues. Now it's time to install the propeller. The installation on the lower part of the hull is a delicate matter. The propeller was cast in one piece in a specially made mold. With its 92 tons and 10 meters in diameter, it can't be transported by air. So it's transported to the shipyard by ship. The last meters of the journey are conducted by massive cranes, which carefully load the propeller into the basin. The first thing that has to be done is to prepare the propeller shaft. Meticulous wrapping protects them from contamination. Nothing should interfere with the installation of the propeller. Now the propellers slowly moved forward. Then, meter by meter, lifted and aligned. But how do you attach a 92-ton propeller? How do you manage to keep these massive parts completely still? The answer? Oil pressure. The men don't help. The propeller simply moved into place by oil pressure, where it's finally attached. Now the oil's injected. It's filled through this huge nut, and the propeller is precisely attached to its axis. The oil pressure increases as the entire team watches carefully. It's under constant observation. Adjustments take place directly on the hull, the old-fashioned way. Once the propeller's attached, the oil is collected to be reused later. Now the screw can be uncovered. Tonight, this brand new engine is reassembled. This time, however, directly on board the ship. This is the lid, the upper part, the last missing part of the engine. The ship has to be able to transport hundreds of tons of goods without anything slipping. The massive piece hovers over the ship at a height of more than 20 meters before it's lowered into the heart. Everything's already prepared. The crankshaft and pressure pistons are just waiting for the last part of the engine to be inserted.
Quand on procède à l'assemblage d'un moteur comme ça, c'est un petit peu comme de la précision sur un moteur de voiture de course ou sur un réacteur d'avion.
Now the parts just need to be attached to each other. The ocean's a particularly hostile environment where the hull is put to the test. The salt and friction erode the paint. It's possible that entire layers of paint peel off. This clearly slows down the ship. The ship needs to put more pressure on the engine to maintain its cruising speed.
À ce moment-là, ça crée des turbulences et on augmente la consommation. Les filets d'eau ne glissent plus.
Controlled fuel consumption is a core feature of container ships. So the painting of ships is extremely important. It's crucial that mussels or any other organism can't attach to the ship. Painting is carried out in several stages.
Il y a plusieurs couches, de manière à protéger l'acier de la corrosion, de manière à ce que le navire glisse le mieux possible dans l'eau. Il y a plein de choses techniques derrière la peinture. Ce n'est pas que de la couleur.
Before applying the last layer, it's crucial to make sure the previous layer is perfect. And that's never the case on the first try. You can always find a mistake somewhere. An engineer examines the outcome himself. To be able to perform a comprehensive inspection, he climbs onto the freight elevator. But an inspection like this can be dangerous.
Whoa, whoa, whoa. Go down, down.
At this altitude, the wind sways the gondola quite a bit. If the ship's side isn't perfectly smooth, the spot is leveled with a grinding machine and repainted.
So this is the remaining. Once they will cut, we will do repair one more time.
Yes.
Okay.
An enormous job that has to be carried out on each of the ships. The total area to be covered is around 950,000 square meters. That's the length of 135 soccer fields.
Il faut savoir que le total du poids de la peinture peut faire jusqu'à 1% du poids du navire.
The last layer of paint can now be applied. This will take 1 to 2 days. Nearly 1 million liters of paint are used for each ship. About 2/3 of that protects the part of the hull that's underwater. This extraordinary container ship will carry a significant amount of goods, the equivalent of nearly 1 billion cell phones. Whether on the bridge or further down in the cargo bays, everything's transported in standardized containers. 12 containers can be stacked on top of each other in the cargo bay. When one's full, it's closed with a so-called hatch cover. Then another 12 containers can be stacked on top from the outside. Absolutely everything is transported in these containers.
C'est tout transporté dans les conteneurs. On va transporter du bois, des minerais, des matières transformées, des téléphones, des déménagements, des voitures.
Of course, the cargo also contains fresh products like fruits and vegetables. You need refrigerated containers for that. They're connected to the ship. The warehouse has to be permanently ventilated because it produces heat.
Donc là, je suis en train de regarder les bouches de ventilation. On peut mettre jusqu'à 2000 conteneurs réfrigérés dans les cales du navire, donc c'est très important d'avoir une très bonne ventilation pour pas que les cales surchauffent.
A cathedral of steel on a massive scale.
Ça représente 50 000 mètres cubes. La cale fait 31 mètres de haut pour 56 mètres de large. On peut charger jusqu'à 12 conteneurs les uns sur les autres et 22 conteneurs dans la largeur. Donc il y a 11 cales comme celle-ci.
But how can so many containers be loaded and unloaded? Next to these ships, a truck looks like an ant. Huge cranes are used to load the cargo into the ships. They're lined up on one side of the ship, and their arms are long enough to reach the other side. The containers loaded by the cranes are stacked using a rail system. So the container towers get higher, layer by layer in the storage facilities, and on the upper deck too. The system's functionality is tested beforehand using a very particular method.
26, 10, 32, 50.
A so-called container dummy is used for this, a replica that has the same dimensions as the real containers. An engineer checks to see if there's a problem. The slightest twist or any other distortion of the rails is noted and corrected. The moorings in the ground are also inspected. The cargo shouldn't move at all while being transported. But everything seems to be under control. Today, the engineer of the shipyard has done his job. Whether in calm or stormy seas, nothing's allowed to move. The containers must be prevented from falling into the ocean. To prevent this from happening, they're attached to the ship's structure above the bridge and to each other. This is done with so-called twist locks. Nothing can happen using this system, no matter how high the waves, no matter how bad the storm. The place where everything on board comes together, the center, the brain, is the bridge. Matthew's looking at it today. This is where the ship is steered when out on the ocean. The command bridge is still under construction. Workers are now laying the last cables and connecting the navigation devices.
Il faut savoir qu'il y a plus de 750 km de câbles sur le JAC-SAAD et des milliers de connexions à vérifier.
In addition to all the high-tech gadgets, you'll also find a few very classic navigation aids.
On a ici la barre. Ce qui est fou à imaginer, c'est que cette toute petite barre va permettre de faire tourner le JAC-SAAD et c'est 285 000 tonnes une fois chargé.
But how do you dock such a massive ship? How do you manage not to damage the ship's wall, which is only 1.5 centimeters thick? Two specific outposts are detached for this maneuver, one on the port side and one on starboard. They know all the necessary commands.
Donc là, tu as la console déportée, je l'ouvre. Lorsque je veux mettre le bateau à quai, ici, je viens à cette position ici et je regarde le quai en bas. Je vais utiliser le propulseur d'étrave qui est là. Quand je mets les commandes à droite, le navire va aller à droite. Je remets à zéro. Quand je mets les commandes à gauche, le navire va aller à gauche. C'est l'avant qui est dirigé par ce système. Avec cette petite manette, je commande un moteur de 85 000 chevaux qui est directement relié avec l'hélice.
A maneuver that requires a lot of sensitivity. It's executed at a speed of 0.4 kilometers per hour. The problem is, despite the low speed, you can never see the bow and stern of the 400-meter-long ship at the same time. To solve this problem, a system called Smart Eyes is used. It contains 8 cameras distributed around the ship, providing an unimpeded view of the entire length. This allows the container ship to be moved close to the dock wall without great risk. After a busy year and a half, the construction of the first container ship, the Jacques Sadé, is coming to an end. The other 8 ships will be completed over the next 8 months. For the first time, the Jacques Sadé goes out to sea. There's a 15-day test phase where all the equipment is tested under real conditions. The tests are controlled from the command bridge, where all the equipment's interconnected. But the equipment alone isn't enough. It's only an aid to navigation. A machine can never replace a human being. The experience of the team is what matters.
Le navire est l'un des navires les plus informatisés électroniques du monde. On a toutes les informations que l'on désire. Toutefois, commander un navire, c'est croiser les données et être sûr de ce qu'on lit sur les écrans.
Speed 24611. Distance 7596. Okay, thanks.
Every electronic device is tested, the mechanics too. How will the brand new engine respond? Speed tests are performed.
3, 2, 1, start!
During the test today, the engine performs as it should. There's another test awaiting the ship tomorrow. When the engine's off, the ship should stop moving. Now comes one of the most symbolic pieces of equipment, the anchor, which of course is also inspected. Like the ship itself, the anchor is enormous. This is where the anchoring is rehearsed and the performance of the anchor winch is tested.
J'ai regardé l'ancre, elle est bien droite.
This is the name given to the mechanism which returns the anchor to the ship.
Donc nous avons mouillé l'ancre par plus de 100 mètres de fond. Et maintenant on vérifie les performances du gain d'eau. On vérifie que le moteur est capable de remonter le poids de la chaîne et le poids de l'ancre qui pèse plus de 27 tonnes.
And that doesn't even include the chain links. Each individual link weighs 300 kilos. The total chain weighs about 372 tons. That's more than the weight of 60 African elephants. After a few minutes, the anchor rises to the surface. The ship appears ready to sail the world's oceans. With the inauguration of the first ship, the French shipyard has won the race against time. 9 gigantic revolutionary container ships were built in record time on this huge shipyard. The French company's gamble has paid off. The first completed ships will soon be traveling their routes. The others will follow. The global flow of goods continues to increase. Today, 90% of freight is transported by sea. 100,000 cargo ships already navigate the seas, so improving their life cycle assessment is an important goal for our planet.
Le monde maritime, d'une manière générale, est en train de vivre une révolution très importante. Le défi environnemental du transport maritime, il est immense.
The liquefied natural gas improves the life cycle assessment of the ships to protect the ocean, air, and the ports. But what will transportation look like in 20 or 30 years? Engineers are already busy developing future-proof solutions. The challenges ahead are daunting. Ultimately, the goal has to be an end to CO2 emissions.
Aujourd'hui, on n'a pas la solution sur la table, technologiquement, mais on y travaille tous. C'est une quête, une opportunité fantastique. Libérons les idées, libérons les cerveaux pour trouver les solutions.
Of course, constructing container ships like these is an enormous financial, economic, and technological challenge. But that's not all. These ships are also a great human adventure. Together, these dedicated women and men have accomplished a great achievement. Together, they overcame that challenge. A genuine challenge, as if made for the 21st century.